So our topic is serial and parallel processing. Serial processing. Serial processing is a powerful mixing technique that can produce effective and aggressive signal processing results without harshness or unwanted artifacts. Serial processing is simply using more than one of the same type of plug-in or signal processor on an instrument or vocal. So types of serial processing. Serial processing have commonly four types: serial compression, serial deesing, serial EQ, and bus processing. So let's start with serial compression. Serial compression is an effective tool for controlling dynamics, shaping transients, fattening up sound, adding harmonics, and etc. Serial compression can be used to apply large amounts of compression without creating unwanted artifacts or distortion. However, it can also be used to simultaneously apply different types of compression to one sound. Serial compression can also be used to fatten up your sound or add harmonics to help an instrument cut through the mix. For instance, say you have a dynamic vocal track in a busy mix. To help the vocal to sit on the top of the mix, you could use a compressor with a fast attack speed to tame transient peak, followed by a compressor with a slower attack and release to gently squeeze the track for more consistent average levels. This results in peak and RMS compression is great for local.
Serial de-essing is a technique used in audio processing to reduce or eliminate sibilance, which refers to the harsh s or sh sounds in vocal recordings. It involves using multiple de-essing processes in series to achieve a more controlled and transparent result. So in serial de-essing, multiple de-essers are used in succession to achieve a more gradual and natural reduction of sibilance. Each de-esser is set up with different parameters such as threshold, ratio, attack, and release times. Now, bus processing. Bus processing, also known as group processing, refers to the technique of applying audio effects or processing to multiple audio tracks simultaneously, typically by routing them to a common bus or group channel. It allows for the collective treatment of multiple tracks or elements within the mix, providing cohesion, balance, and creative control over the overall sound. So, bus processing is a powerful technique used in audio production as it allows for efficient and unified control over multiple tracks. It helps in achieving a cohesive and balanced mix while providing the flexibility to shape and enhance the overall sound in creative ways. Now, serial EQ, think of serial EQ like painting a picture with different brushes. Each brush represents a different EQ stage, and by using them in sequence, you can make precise adjustments to the colors and details of the painting. So, serial EQ is just like using different brushes to touch up and improve the sound layer by layer until it sounds better.
So till now, we were learning about serial processing. So let us see what is parallel processing. Hence, parallel processing is a computing technique when multiple streams of calculation or data processing tasks co-occur through numerous central processing units working concurrently. Parallel processing generally refers that you divide a task between at least two microprocessors, and the idea is very straightforward. Here, a computer scientist uses specialized software created for the task to break down a complex problem into its component elements. Then, they designate a specific processor for each part, and so as to complete the entire computing problem. Each processor completes its portion, and the software resembles the data to solve the complex initial challenge. When the processing is being done in parallel, a big job is broken down into several smaller jobs betterly suited to number and size and type of available processing units. After the task is divided, each processor starts working on its part without talking to the others. Now, let us see what are the examples of parallel processing. So first one is supercomputers, which are being used in astronomy. Then making predictions in agricultural field. Other than that, risk calculations and cryptocurrencies in banking, video post-production effects, and accurate medical imaging. So, this is how the parallel processing works.
Flink's classification is based on the division into operation of a control unit and data processing unit instead of its function and structure communication. So Flink's classification are divided into many different types like single instruction, single data, multiple instruction, single data, single instruction, multiple instruction, multiple data, single program, multiple data, massive parallel processing. So all these other different Flink's classification types in which data are given by CPU and are streamed using data streaming from memory locations.
As we have seen, different categories of Finn's classification. First one is single instruction, single data, SISD. In this type of computing called single instruction, single data, SISD, a single processor is responsible for simultaneously managing a single algorithm as a single data source. A computer organization having a control unit, processing unit, and a memory unit is represented by SISD. It is similar to the current serial computer. Instructions carried out sequentially by SISD, which may or may not be capable of parallel processing. It depends on its configuration. Next one is multiple instruction single data MISD. Multiple processors are standard in computers that use the multiple instruction single data instruction set. While using several algorithms, all processors share the same input data. MISD computers can simultaneously perform many operations on the same batch of data. Next one is single instruction multiple data SIMD. Computers that use the single instruction multiple data architecture have multiple processors that carry out identical instructions. However, each processor supplies the instructions with its unique collection of data. SIMD computers apply the same algorithm to several data sets. The SIMD architecture has numerous processing components.
Multiple instruction, multiple data (MIMD) is a type of parallel computing architecture that allows multiple instructions to be executed on multiple datasets simultaneously, each capable of independently accepting its instruction stream. These kinds of computers have many processors. Additionally, each CPU draws data from a different data stream. Each processor or core can execute instructions on it at its own pace without being synchronized with other processors. MIMD systems can be classified into two categories based on memory organization: shared memory and distributed memory. A MIMD computer is capable of running many tasks simultaneously. It is commonly used in modern parallel computers and multiprocessor systems, for example, supercomputers. The following block diagram shows the working of MIMD. Single program multiple data (SPMD) is a parallel programming model in which multiple processors or cores execute the same program but on different portions of the data. It is a common approach used in parallel computing to achieve parallelism and speed of computation. In an SPMD system, all processors or cores execute the same program code, but each operates on a distinct portion of the data. The program is designed to handle parallelism, where the same set of instructions is applied to multiple data elements simultaneously. Each processor or core works independently on its assigned data, and communication between processors is typically achieved through explicit data exchanges or synchronization points. SPMD is a message passing programming used in distributed memory computer systems. A group of separate computers, collectively called nodes, make up a distributed memory compute. The following block diagram shows the working of SPMD. Massively Parallel Processing (MPP) refers to a computing architecture that involves the use of a large number of processors or computer nodes working on together in a parallel to solve complex computational problems. It is designed to process massive amounts of data and perform computations in a highly parallel and distributed manner. With each CPU using its operating system and memory, this coordinated processing can be applied to different program sections. In an MPP system, thousands to millions of processors or compute nodes are interconnected through a high speed of network. Each node typically consists of multiple processors or cores, and each processor works on a specific portion of the data independently. MPP systems are designed to scale horizontally by adding more compute nodes to increase processing power. MPP processors typically communicate through a messaging interface and can have up to 200 or more processors working on an application. It functions by enabling the transmission of messages and between processes via a set of corresponding data links. MPP systems are widely used in various fields, especially for big data analytics and scientific simulations.